Welcome, this is Algebra 2, Unit 3-9. How do you graph factorable polynomial functions? I think you guys will really like this one. If a polynomial function is factorable, then we see some really cool things. Here's how I graph these. I'm just going to show you my short way. If I look at this is x. For my leading coefficient, it would be x times x is x to the squared, times another x would be x to the third, times another x would be x to the fourth. So I know this is an even function. So first thing that I mark down, it's going to be even x to the fourth. And sometimes I just put that in my mind's eye, but I'm going to mark it on the board so you can put it in your notes and see what I'm talking about. So if it's x to the fourth, I know my end behavior, and I put that on here. It's positive, because there's no negative out front, so I know that my end behavior is like that. Now the cool thing is, my zeros, all I need to do is set each factor equal to 0, and I'll have my zeros. So x minus 1 would be 0 when x is 1. So I put a line right at 1. That means the graph's going to go touch or go through right at 1. X equal 2 would be another 0. X equal 3 would be another 0, and x equal 4 would be another 0. Okay, now I do notice one other thing. These are all to an odd exponent. They're all to the first. Remember, with odd polynomials, the line goes through the x-axis. So I have my end behavior. I just attach it. I go through, 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 through. I move this end behavior over where it fits the graph more. And there's my graph. Okay? So, it's a good sketch. On the next one, again, I have x squared times an x would be x to the third times x would be x to the fourth. So again, I have an even x to the fourth. So my end behaviors are going to be going up in the U shape. This time what I notice, x would be equal to 3. And that one's to the first power, so I know it goes through. X would be equal to 2 on the first power, so that one goes through. The x to the first, notice how it's to the second power, it's even. That means that it's going to be tangent, just like we see on an even function. It comes down and it makes a U. It touches the x-axis. So, now I connect my end behavior, and I can have that one sketched. So, my zeros are shown in my factors. If they're to an odd exponent, they go through the x-axis. If they're to an even exponent, they touch or go tangent to the x-axis. So the next one, at 1 it's 3, and at 2 it's 1. So they're going to go through here. This is to the fourth power still. So I can picture it. Okay. And now this one, it's at the 1, and it's an even, so I know that it's tangent. Okay, now a couple things that I want to make sure that you get. You can look at your factors. You can say I have zeros at 1, 2, 3, 4, and they each occur one time. In other words, they're raised to the first power. And so that causes them to cross through. Okay? Because it's a 1, it causes it to cross through. On this one, I've got zeros at 1, 2, 3. Now, this one's twice. This one's once. Both of these are once. Okay? So this one means twice that it's tangent. That one, those mean it goes through. Okay? Here, I have 1 and 2. This is 3 times. Since that's odd, it means it goes through. And this is 1 time. Odd, it means it goes through. This one is at 1, but it occurs 4 times. Being even, that means that it's tangent. Okay? This twice means tangent as well. Now, what you need to make sure that you're aware of is they were all to the 4th power, 4th power, 4th power. I didn't write it on these two, but look at the number of zeros we have. We have 4, we have 4, we have 4, and we have 4. That should always match up. Your power, your leading coefficient power, should always match to the number of zeros you have. So now when we look at this, we are asked to sketch this. First thing I look at is in behavior. Well, this is x the second. That would be another one. So that's 3rd, 4th, 5th. X the 5th is an odd function. So I would graph it by popping my arrows in there. It's a positive odd function, so it's going to go like that. Now, odd number of zeros should occur on my x-axis. I should have 5 zeros. So I go to positive 3. There's going to be one of my zeros that passes through. 2 is going to be another one. Positive, oh, that's a positive 1. X would have to be a negative 1. So there's another. And at x negative 2, I'm going to have a tangent. Okay? It doesn't go through there. Now that is enough for me to identify, and I put the steps here for you to write into your notes. It's enough now to sketch this. Am I absolutely accurate with everything? No, but it's enough to get it sketched, enough to give you a mind's eye picture of it. So it would come up here, have a tangent, go through, come over to the 2, up to the 3, and they should all connect. If it doesn't connect right to your end behavior, you know you've got a mistake there. Okay? Now, we might be asked to graph this and they didn't put it into factors. So then you've got to use your skills from the last unit to discover, well, what are my factors? Here's how you can find potential factors of this polynomial. You take your constant factors. Your constant is 12. So I think of all my factors. 1, 2, 3, 4, 6, 12. Okay? Now I put them over the leading coefficient factors. Fortunately, my leading coefficient is 1. That makes it nice. When it's a number, boy, you can get a lot of these potential factors and it can become a real burdensome problem. I wouldn't say to hang up on those really hard ones in class. Find some with 1s in the front. Use those. So, or 2. So I would have 1 as my only factor on the bottom side. Otherwise, see, if I had 2 factors, I'd have to double this to show both. Now realize you could have plus or minus on all of these. So here are all my potential factors. This is going to be a little bit tiresome, but remember, one of the equalities you have to learn in Algebra 2 is perseverance on problems. So I do expect you to be able to work these out in your final exam and on this coming quiz. Okay? The first one that I always go to is the 1 because it's really easy. So I'm going to try synthetic division with x equaling 1. So I come down with my coefficients. I have 1, -1, -8, and positive 12. Usually 1 or -1, I can typically find a factor on those. So I drop that down. 1 times 1 is 1. Add those, that would be 0. 1 times 0 is 0. -8. 1 times -8 is -8. That equals 4. That one didn't work because I do have a remainder, so that's not a factor. Now I try -1. Okay? I just go back, and you may want a whiteboard to do these so that you don't waste a lot of paper. Okay, so -1 times 1 is, you drop down the first one, so that's 1. -1 times 1 is -1. negative 1 is negative 2. Negative 2 times 1 would be positive 2. Negative 8 plus 2 is negative 6. Negative 1 and negative 6 is positive 6. And we have 18, so that's not a factor. Okay? Hope I haven't made a mistake, because usually a 1 works. If you caught a mistake, you know I'm coming back to it here in a minute. Okay? So now I go on to 2. Drop the 1. 1 times 2 is 2. 2 and negative 1 is 1. 1 times 2 is 2. Negative 8 and positive 2 is negative 6. 2 times negative 6 is negative 12. That is a factor. Okay? So I can now stop on having to do synthetic, because I can fill in, I know this is an x squared plus x minus 6. I know this being a positive 2 there means that it's x minus 2. Now I need to factor this, hopefully with the x game. Negative 6 on the bottom, 1 on top. I would say, oh, that would be a positive 3 and a negative 2. Because it has a 1 in front, I can go right to my factors, so I get x plus 3 and x minus 2. This is x minus 2. And now I can graph it just like you have these others. Sketch it out. I know that I have 2 crossing, or I mean a tangent. Let me just write it out. X minus 2 squared, because they occur twice, and then x plus 3. I know this is to the 3rd power, so I've got my end behavior like this. X minus 2 would end up being x equals positive 2, so it's over here. And it's going to be tangent. X plus 3 would be x is equal to negative 3. And it goes through. Okay? So I connect this, going through, come over here, and I go tangent at the 2 and back up. Okay? That's how you sketch these. Have some fun with it.